All right, welcome back everybody. We are diving into project 12 of our Arduino starter projects. This project is knock lock, knock knock, unlock. And basically it's looking at the piezo again, where it's actually taking vibrations from the surface, right? So if we knock on the tabletop that the device is on, we get some motion in our servo motor. So with that being said, that's kind of the gist. Let's go ahead and dive into the code. Right off the bat, with this particular project, there's quite a few variables in here, just simply because of the way that some of the state is maintained for locked and unlocked and how many knocks were identified, things along those lines. So, just right off the bat, just be prepared to be working with some state variables, but it's not too terribly bad. So here we're at our typical starting point with setup and loop. And the first thing that we're going to do, just as we've done in our previous projects that needed the servo capabilities, we're going to include the servo header. So we get the import of the servo library. And we can now have our variable, which we just call my servo, right? And this, just like with the LCD, the servo library takes care of a lot of the inner workings for writing to the servo to set whatever value we're going to set, whether or not it's locked at 90 degrees or unlocked at 0 degrees, things along those lines. But stuff you've seen before. So next, what we're going to do is we're going to declare which pin we're going to use to read in from the button, right? And this switch pin, if the button is pressed, this is what we're going to be reading in the high-low signal on. And in addition to that, we have the LEDs, the yellow, green, and red LEDs in this project. And here we're just going to line those up with our pins 3, 4, and 5. And those are just going to be the pins that we write out to turn the LEDs on, i.e. high, or turn them off, i.e. low. Stuff you've all seen before. Here in the piezo, we are going to read in on the analog 0. And for the server pin out, we are going to write out on digital pin 9. Next, what we're looking at is the quiet and the loud knock. There's a little bit of math that goes into determining whether or not the knock was detected as a little bit quieter rather than one that's a little bit more aggressive, I guess, a little bit louder. We'll look at these later on, but 10 and 100 is really kind of the spectrum that they're putting in. Remember, when we look, and this will make more sense when we look at the math for the function call later on to determine whether or not we have a quiet or loud knock. We can, from an analog signal, and we're reading in from the piezo on A0, so we can get from 0 to 1023. And later on, we just want to have that value down between, we want it to be 100 or less. So therefore, right, since we can get up to 1023, we're going to subtract that 23 just to give us an even 1,000, more or less. And then we're going to divide by 10. And so if we had a 1024, 1023, we subtract the 23 or 24, we get to 1,000, then we divide that by 10, the maximum we would get is 100. And so that's where these numbers are kind of coming from that we're playing with, and we'll look at more of this later on. Next, we need to hold the current value from the piezo sensor, and this is what the knock value is. The knock value is going to be the actual analog value that we read in from the sensor, and the switch value is what we're reading in this case from our pin 2 when the user presses the button or releases the button, right, high or low. And then we have another state variable telling us, it's a Boolean, right, true or false. That's the only two states it can be in. Telling us whether or not our state is locked or unlocked. Unlocked being false, locked being true. And then the next thing we're looking at is the number of knocks, right? The user knock 1 time, 2 times, 3 times, and we increment that number just to kind of keep track of things, right? And that's just the way the code is set up. And we'll look at this in a lot more detail. But here's the variables, right? So there's a lot of pins, but understanding some of the quiet versus the loud knock, and then we have the more or less 4 variables that we're going to use to control state: the knock value, the switch value, the lock boolean for locked, and the number of knocks. So with all this in place, let's go ahead and start to jump into the setup of our program. And right off the bat, we're going to use the myServo variable and call the attach method. And that we are going to attach to pin 9, right? Because we have the servo pin defined as a const, right? We have that as 9 in our variable declarations. Here we attach our servo to pin 9. Again, stuff you've seen before. Next, we have our LED pins, right? And we're just setting these up as outputs. We have these set at 3, 4, and 5. Right, and those are just going to be the pins that we write to the LEDs to turn them on or off, right, high or low. In addition to that, we need to be able to read in from our button. We've seen this before, right? And in this case, pin 2, we're going to read whether or not the user's pressing the button or not. And here, when we first start up, we are going to set our green LED to high. Right, so we're just writing out to the green LED pin. We're setting it to high, means the green LED when we first start up is going to be turned on. And here we are again going to use the servo library from our servo variable. We're going to call the right, and we're going to give it the number of degrees we want it to rotate. Right, in this case, we're just putting it at 0 degrees. In the booklet, they have all this cardboard stuff in there that you can like fold the box up and down, and if you want to do all that, great. When you go to set the servo to 0 degrees, we'll close the box. 90 degrees, we'll open it, and you'll see the 90 degrees later on. But anyways, right now we're setting it to 0, so your box would be unlocked, open. And then finally, we're going to set the serial configuration. Again, baud rate 9600. We have that declared. I'm going to leave out the print statements in most of the code, or really all of the code in this program, just simply because it confuses it makes the code look more complicated than it needs to be. If you want to put in the print statements, feel free, but to get the learning experience, I'm not going to put in any of the system or the serial print commands. I'm just still initialize the serial, so anybody out there, just be easy for you to put your print commands in, but I'm going to leave them out for this program. All right, so that's pretty much it for the variables and setup. And what we're going to do now is go ahead and move into our loop. Now, the code that I have in this loop function, I've cleaned it up from the booklet some. I've made it a little bit more concise, and so I'm just going to walk through it. It's going to be a little bit different from the code in the booklet. Not functionality. The functionality is identical, but this just puts the code in a little bit of a cleaner spot. So you'll notice here that right off the bat, we're going to look and we're going to determine whether or not we're in the locked state or not. If we are unlocked, then we don't care about knocking, right? Because we're unlocked, the door's open, come on in. So right off the bat, we're going to look and we're going to say, is locked equal false, right? Is the door open? And then if it is in fact open, we are in an unlocked state, we're immediately going to hit the digital read and we're going to read from the button press. And if that button press is high, then we know that the user's switching from an open, unlocked state to a locked state. So this next conditional, right, we read from the digital input, and then the very next line, if the switch value is not equal to high, right, we read from the digital input, right, so the door's open, we read from that digital input, the button has not been pressed, so we're not going to change anything, right? So the switch value would be low, right, not equal to high, and so we just return. There's nothing more to do. You're unlocked, we read the button, you're still unlocked, done. Moving on. However, if we're in the unlocked state, we read from that digital read, right, from our button, and it is in fact high, right? So the switch not equal to high would be false, so we wouldn't go into the return statement. Then we know that the user's pressing the button because the button came out as a high value. So we're immediately going to put our locked state to true, meaning our door is now locked. And what we're going to do as soon as we say the door is locked is we're going to put the red LED into a high value. So we're going to turn on the red LED. We're going to put the green LED into a low value, low state. And so essentially we're going to turn off the green LED. The next thing we're going to do is we're going to, again, referencing the myServo variable, we're going to write out 90 degrees. And in this case, if your box is open, it should now be closed. So we rotate our servo 90 degrees and we delay for 1 second. And that just gives the servo enough time to actually make that rotation. And that's all that is, right? So within this initial block, we take care of if we are unlocked and we still are unlocked, we return. If we are currently unlocked and we come back and they press the button, now we know that we're locked. We have the red light turned on, the green light turned off. We have the servo turned to 90 degrees, and now we're just waiting for the servo to finish its rotation, and we wait for 1 second. At this point, we know we're in a locked state, so we want to pay attention and listen for knocks, right? Because we're now, the door's shut, it's locked, we need to listen for somebody knocking. So I'm just going to move that code a little bit out of the way. And what we're going to do is we're going to read from the piezo, and we're going to get the knock value. In this case, it's going to be a value from our analog input on A0, and it's going to be a value between 0 and 1023, okay? Now, once we get that knock value, the very next thing that we're going to do is we're going to say, do we currently have the number of knocks that the user's executed? Is it less than 3? And is it greater than 0? Okay? So is our knock value, or I'm sorry, is the number of knocks less than 3 and is the knock value greater than 0? Right? Because if it came in as 0, technically that's nothing. The piezo didn't pick up any value, so we're just looking for a number of knocks less than 3, and if the knock value, if the sensor's picking something up, right? If those two conditions are met simultaneously, then we're going to check for the knock. And if you remember a little while ago, we had mentioned for that knock value, right? It comes in on the analog. So we can have from 0 to 1023. Here in the booklet, they subtract 24. So technically, if it is 1023, you can get 999. But then they're dividing by 10, right? And this is what we talked about to get the values below 100, right? So, if it's 800, you're just kind of taking that rounding error, dividing it by 10. So you're not going to get a value greater than 100 is what they're getting at here for the call to the check for knock function. And we'll look at the check for knock function in a little while. So that check for knock function is going to take the value that we pass in. Now it's going to be between 0 and 100. And if it does detect that it's between 10 and 100, if you remember our quiet knock and our loud knock, that's what the check for knock is going to look for. If it does detect a knock, it's going to return a Boolean value of true, and we're going to increment the number of knocks that we've detected. Okay, and so right now we just say if we have less than 3 knocks and our knock value is greater than 0, we're going to check to make certain that it's between the quiet and the loud. And if it is, we're going to increment the number of valid knocks that we've detected. Okay? So again, we're going to move that a little bit out of the way. And here, the next thing we're going to do is we're going to say if the number of knocks that we've detected is greater than or equal to 3, then you've knocked 3 times. You've done the magic knock. So the first thing we're going to do is unlock ourselves, right? That's the very first thing that you see inside this conditional. The next thing is you're going to, again, call the right method on our servo object, and you're going to set the angle to 0. Essentially, if you have that cardboard thing, it's going to open back up, right? Here, we're delaying 20 seconds just to give the servo a little bit of time to rotate. And next, we are going to write out to turn the red light off and the green light on, right? Because now, again, we're unlocked. And the very next thing we have to do is make certain that the number of knocks that we say we've detected goes back to 0, right? Because we've now gone from a locked state to an unlocked state. And so we're not going to keep track that we previously had 3 knocks. That just doesn't make any sense, right? Next time we lock it, we want to start from 0 and listen for 3 knocks again. And so that's what's going on here. And again, if the number of knocks is 2, this conditional is not going to even get executed, right? We're not going to do anything. 2 knocks isn't going to determine whether or not we're locked or unlocked. Okay. Now, the next thing I want to take just a really quick note of is we need to finish off this check for knock function, right? So here is the logic for really determining whether or not our piezo has determined that we have a knock. That's what this function is going to be looking at. And so with that, let's go ahead and jump over and take a look at that. What I have here, the 3 ellipses at the top just represent all the code that we've done. Same thing with the setup in the loop. The 3 ellipses, all the code that we've done is still there. And so what I'm going to do after the declaration of all the variables is I'm going to put in the function for check for knock. And here in the function signature, you can see that it returns a Boolean and it takes that integer as a parameter. And we just named the integer value, right? This is the knock value minus 24 divided by 10. That's what we're going to get for this, for the value passed in as the parameter to the check for knock function. And the first thing we're going to do is we're going to say, is that value greater than quiet knock? And if you remember, quiet knock was set to 10. And if that value being passed in is less than the loud knock, and if you remember, that was 100, right? And so that's where they are going from 1023, they're minusing, or they're subtracting 24 from a maximum of 1023. So we would get a 999 is pretty much our maximum value. And so that's why we're doing less than the knock value. We could, if we just subtracted 1024 or 23 from the value, right, 0 to 1023, then we could get 1000 divided by 10, and we would have to say if the value is less than or equal to knock. And so just kind of be aware of that's where they're kind of going with the value part of less than knock, right, as opposed to less than equal to. If that's the case, we've said, hey, we have a valid knock. We are going to turn the yellow LED on. We're gonna wait 50 milliseconds, and then we're gonna turn it back off, and then we're gonna return true. And that's an indication that the piezo has detected a knock, right? That the yellow LED coming on and going off, that's a detection of a knock. Now, if the value that we pass in is either greater than the loud knock or less than or equal to the quiet knock, it's not going to fall into that if statement at all, right? It was either too quiet or too loud, I guess. And we're just going to return false. The knock was not a valid detected knock, right? And so, again, they have an else in the book, which serves absolutely no purpose, right? So if I did else return false, it's a waste, right? It's not concise code. So again, little bit different here than what you see in the booklet, but that else serves absolutely no purpose whatsoever. So here I'm just returning false. Now, the one thing I do want to point out is it's very likely you're going to have to play with some of these numbers. We'll look at the board later on, and really I've tried it on multiple surfaces, and depending on what surface I'm on, whether it's a hardwood floor or the kitchen counter or one of my workstations or one of my desk, each one, the piezo seems to detect the vibrations at different levels and different frequencies. So guaranteeing you get that 3 knock is not, on this particular board, isn't really a guarantee. You'll find yourself having to play around with a lot of these numbers, and that's just the nature of the beast on, this sensor. It's not a high-end sensor necessarily, right? So you may get some strange results, but again, you're just gonna have to play around with some of the numbers, and it depends on what surface you have it on, things along those lines. So I'll talk a little bit more about this, and you'll see it in action when we move into the board. But for now, that's all that there really is to the code for this one. Not too terribly much, a couple things, a little bit unique with the function call, things along those lines. But I think it'll make a lot more sense, if it isn't already, once we walk through the board, which we're going to do in the next video. So that's it for now, and we will see you in the next video. Take care, everybody.